Good morning. So today we are going to be working through warm-up day 11. And as usual, I'm showing you the answers first. So go ahead and pause here if you want a chance to check your answers. And then after you're done checking answers, you can press play again and we will move on to actually working some problems out together. All right. So number one, Emily spends 12 minutes cooking dinner. Jeff spends 3 times as many minutes cooking his dinner as Emily spends. So if we know that Emily spends 12 minutes cooking dinner and Jeff spends 3 times as many minutes, then we're multiplying, right? We're going to multiply the 12 minutes that Emily spends times the 3, and that's going to equal how many minutes Jeff spends cooking. And if we want to solve that out, all we have to do is 12 times 3, which is 36. Number 2, at her cat's birthday party, Alicia has 8 tins of tuna to divide between 6 cats. She wants to put an equal amount of tuna into each bowl. What amount of tuna does Alicia need to put into each bowl? Well, first of all, we got a fraction because we're going to divide, right? She has 8 tins, so that goes on top. She wants to divide it between her 6 cats. So 8 over 6 we can reduce to 4 over 3. But 4 over 3 isn't one of my answers, right? I've got fractions and I've got mixed numbers, but I don't have any improper fractions. So let's take this 4 over 3 and let's turn it into a mixed number instead. Now remember, when I'm doing a mixed number, my denominator stays the same, so that's going to stay 3. My whole number is how many times my denominator goes into my numerator. So 3 goes into 4 one time with a remainder of 1, and that remainder becomes my new numerator. So we are looking for 1 1/3 tins per cat. Number 3 is another division problem. Julia has a piece of wood that is 18 feet in length. She wants to cut it into 5 sections of equal length. How long is each section of wood? So again, we have her total feet, which is 18. She wants to divide it into 5 sections. So we're just going to take this 18 over 5 and we're going to turn it into a mixed number. So my denominator stays the same. My numerator is how many times my denominator goes into my numerator. Sorry, my whole number is how many times my denominator goes into my numerator. So 5 goes into 18 3 times with a remainder of 3. And that remainder becomes my new numerator. So 3 3/5 feet. Number 4, look at the expression 4 times the quantity of 3y plus 4. And I'm going to bring this out here a little bit. 4 times the quantity of 3y plus 4. Now remember, distributive property tells us that if I have a mathematical expression inside a parentheses that's being multiplied by something outside the parentheses, then I can do this number times this plus this number times this. So that looks like 4 times 3y plus, because our sign just comes down, 4 times 4. So 4 times 3y is 12y plus 4 times 4 is 16. So that's number 4. Number 5. During a physics lab experiment, students glued a 100 milliliter graduated cylinder to the top of a helium-filled balloon and attached it to a lab tabletop with a ribbon. The students then added water, 15 milliliters of water at a time, to the cylinder and measured how far the base of the balloon was from the tabletop in centimeters. They then graphed the data and calculated the line of best fit to be y equals negative 7 over 18 times x plus 35. What does the x-intercept represent? Well, the x-intercept is what is x when y is 0. So when y equals 0, what is my x value? So for y to equal 0, it's going to be a point somewhere along the x-axis. Okay, so normally I tell you, if you're bogged down by a lot of words, just look at the question. What does x represent? What does the x-intercept represent? But in this case, I'm actually going to tell you, pay attention to the details. Let's go ahead and draw a picture of what's going on. So I have this graduated cylinder on top of a balloon. And the balloon is attached to a table. Now, as they add water into the cylinder, the balloon gets closer and closer to the table. So the more water they put in, the shorter the distance is between the table. So what they want to know is how much water has to get in here for the balloon to be 0 centimeters from the tabletop, right? When y is 0, that means we're at 0 distance. So they want to know how much water is it going to take for that balloon to be here instead. The question also tells me they calculated the line of best fit. And so they looked at these points and they said, we're going to go about like that as a line of best fit. So if I create my own line of best fit on this graph like I just did, and I look at what's happening when y is 0, well, that's at x equaling 90. 90 what? 90 milliliters of water. So when the cup has 90 milliliters of water, it is 0 distance from the tabletop. There's only one answer that fits that information, and that's letter A. At 90 milliliters, the base of the balloon touches the table. That means my distance is 0. So that one's a little bit more confusing, but again, we start with what's the question asking for, and then if we need to, we draw a picture to better understand what's happening, and then we just follow through, find an answer, and then find the given answers that match our information. Number 6 gives us a scatter plot. and they say select 2 points that define the line of best fit. And basically what they want to know is, if I would draw a line of best fit on this graph, which of these points would actually be on that line? So let's draw our line of best fit. Remember, my line of best fit tries to go through as many points as I can, and it has about the same number of points above the line as it has below the line. So now I look at my points. Well, 0, 0 is right here, and that is definitely not on my line of best fit. 0, 50 is right here, also not on my line of best fit. 0, 60 is on my line. 60, 70 is not on my line. 60, 80 is. And 60, 90, even though it's a point, it's not a point on my line of best fit. And so the only 2 points that define my line of best fit are 0, 60 and 60, 80. Number 7, from a box of 40 cookies, each of 7 students took the same amount of cookies. There were 5 cookies left over. Which equation can be used to find the number of cookies each student took from the box? So if we think this through, we've got 40 cookies in a box, right? I have 7 students who took the same amount of cookies, and I don't know what that amount is, so that's what I'm going to call X. So the 7 students times the amount of cookies that each student took takes care of those student cookies. And then I have 5 cookies left over. And the only one that matches this equation is letter C. Now we notice in my answer box, the 40 is on the right side of the equal sign, and the 7x plus 5 is on the left side. And in my answer, the 40 is on the left side, and the 7x plus 5 is on the right. But that's okay, as long as this equal sign is separating my pieces of information the way it's supposed to be. So I've got 40 on one side of the equal sign, 7x plus 5 on the other side of the equal sign. So I am okay. For number 8, which of these functions is linear? Remember, a linear function is going to be y equals mx plus b. So everything in this equation has an exponent of 1. So the first thing I can knock out is any equation that has an exponent greater than 1 inside of it. So that takes C out of the running. It also takes A out of the running because x times the quantity of x plus 2 is the same thing as x squared plus 2x. So even though A doesn't look like it has an exponent greater than 1, it actually does if we math it out. So C is wrong and A is wrong. Now we're looking for something between B and D. And what we're trying to find is y equals mx plus b. Now if I take D and I solve it for y, I get y equals 16 divided by x. But if I take b and I solve it for y, then I can do 5y equals 64 minus 4x. Or I can shift it around, 5y equals minus 4x plus 64. So I have my y and my x times another number, and my number without any variables. And so B is the answer. All right, number 9. Patricia delivers 8 meals a day driving for Meals on Wheels. Which graph represents the relationship between the total number of meals delivered on a given day? So we know that her total of meals, which would be y, equals 8 meals per day, which would be x, right? So if I create a table on her first day, she has delivered 8 meals, right? Because 8 times x, if I let x be 1, 8 times 1 is 8. But if I look at the days that they give me down here, it's much easier to make x be the values of the days they give me. So let's go to 3. If x equals 3, then y equals 8 times 3, which is 24. So at 324, I want to be on the line. Well, 324, I am not on the line. 324, I am. So B is looking pretty good. Let's try one more. At 6 days, the meals delivered will be 8 times 6, which is 48. So at 6 days, I want to be at 48 meals. Still not on the line. But on this one, at 6 days, I am at 48 meals. So B is my graph that represents Patricia delivering meals for Meals on Wheels. Okay, last one. In the diagram below, the total measure of the angles is 180. What is the measure of angle B? Well, if the total measure is 180, then we know that 45 plus 39 plus B plus 24 equals 180. And these together, 45 plus 39 plus 24 equals 108 plus B equals 180. Then, to get B by itself, I need to balance out this 108, right? So to balance it out, I subtract 108. But if I'm going to subtract 108 on this side, I have to subtract 108 on this side. And that gives me B equals 72. Okay, that is the warm-up. Remember, if you have any questions about this that the video isn't clarifying, you've got Miss Laura right there for you to ask questions and to get some help. So yes, use the video, but if the video is not working for you, go ahead and ask Miss Laura how she would solve one of these and hear how she does it. Because remember, math many times has more than one right way to get to the right answer. I hope you guys are doing well.